Okay, so let's talk about the DC motor. So the robot will be moving forward in this particular project and not really moving backward, but the idea is that you could do so by using this H-bridge. So the idea is that you can let the current go either in the right direction or the left direction, and in that way you can go backward or forward. So in the robot, the control signals of an H-bridge will be derived from two GPIO signals and a PWM signal. So what are we doing? The two GPIO signals control how this motor is connected in this H-bridge, and so that will indicate whether you go forward or backward. And the duty cycle of the PWM signal controls how often it is connected, and therefore it indicates the speed at which you drive. So that is what will happen here. Now for the servo motor, you like to steer. So so what you want to do is you want to actually communicate to this servo motor, and there's a specific protocols, a specific way of communicating to that. So you can steer from 0 to 180 degrees. It's used, of course, in, for example, air in planes that you could build yourself, for example, small toy planes. You can move these particular things, the rudder over here, the elevators, and so forth. And the cool thing is that it's a very simple, straightforward protocol as described by this particular diagram. The servo is controlled by using a 50 Hz PWM signal. That's what you will be programming. That is a signal period of 20 milliseconds, and the angle of the servo is determined by a pulse width. That is the duty cycle of, so 1.5 milliseconds corresponds to the center position. So 1.5 milliseconds out of the 20 milliseconds corresponds to going straight, which is this particular one. If you have only duty cycle of 1 millisecond, you go all the way to the left, and for 2 milliseconds you go all the way to the right. Make sure though that the pulse width is never outside the range of 0.9 to 2.1, because that will actually break the servo. So that's actually it. So connecting the servo, you have 3 wires, which will be the red, black and the yellow wire that you need to connect properly to the PWM and the ground in VCC. So that's actually it. So any questions about this? And if not, then we'll go early to the laboratory. So alright, so that's it. Great.